Hey everyone, I'm Brianna Ummer, and this is my explanation for nodal analysis. Okay, so first of all, we need to understand that nodal analysis is another application of Kirchhoff's current law, or KCL. The law basically states that all the currents going into a node is equal to the sum of the currents coming out. What is a node? A node is defined as a point or branch with three or more connections. In this example, you can see that there are two nodes, one at the top and one at the bottom. The node at the top connects the three resistors, and the node at the bottom connects the two resistors with the ground and the voltage source. To conduct a nodal analysis on this circuit, we must label all the currents entering and exiting the nodes. The initial current is I1. This is equal to 10 amps. This 10 amps then splits into two, one going through the 10 ohm resistor on the top and one going through the 10 ohm resistor at the bottom. We've labeled these currents I2 and I3. Since we know that the sum of the currents entering a node has to equal the sum of the currents exiting the node, we know that I1 must be equal to the sum of I2 plus I3. To find I2, we must conduct a current divider rule. That is, that the current going through a certain resistor is equal to the total resistance divided by that resistor plus the total resistance times the sum of all the currents entering that node. Using KCL, we find that the current I2 is equal to 5 amps. We substitute that back into the I1 equals I2 plus I3 formula to find that the current through I3 is equal to 5 amps. We conclude that I2 is equal to I3. This makes sense because they are both going through 10 ohm resistors. This concludes my nodal analysis example. In summary, to conduct a nodal analysis, we must first identify all the nodes, then label the currents, then use KCL to find the currents. Thanks for watching!